Good morning, everyone. How's everyone doing? Good? Hopefully you enjoyed Andy Jassy's keynote today. And hi, I'm Jim Tran.
Hi, I'm Justin Pirtle.
And thanks for spending the time with us today. Wow, what an audience. In fact, we were told that this theater is where the Blue Man Group used to perform. So if you're here to see the Blue Man Group or another musical performance, we're actually here to talk about serverless authentication and authorization. So just by show of hands, how many of you work on an app where users have to sign up before they can sign in? OK, by show of hands, how many of you work on an app where users have different levels of permissions? So when we work with customers that build applications using serverless architectures on AWS, we're hearing this more and more. Identity federation is a critical part of most applications. And so today, we want to share some of the best practices and tips for integrating identity management into your serverless applications.
So rather than just share concepts or theory, we actually wanted to make these patterns available to you immediately today for your direct use. So we thought it'd be a much better way to show you not only some of the flows and the key concerns, but also a real reference application that you could download and use. And so we built Space Finder. This is our little simple app. It allows you to book conference rooms, allows you to book hotel desks. But we're happy today to basically launch this app. It's a hybrid mobile app that we'll be demoing. And it's available now today, released on GitHub on AWS Labs for all of you. So any demo you see in this session, you can immediately use. Just to tell you a little bit more about Space Finder, this is a hybrid mobile application. So it's using the JavaScript AWS SDKs. But the patterns we show, the flows we show, these would work on any platform or language. It is open sourced under the Apache 2 license, so you can directly use any source code that we put into the application. Now, as much apps start, we started by thinking about our user experience. And Jim and I went to the whiteboard one day. We said, well, let's build an app, Jim. And this was what we came up with. This was just showing our mockups. And what became clear to us was when you looked at these flows of booking a room and all these kind of things, we actually had a ton of UI around how do you sign in, how do you sign up, forget your password, et cetera. And about 40% of our UI in this app ended up being around account management. So it was actually much less trivial than we thought, even from a UI perspective, to build such a feature set. So after we got our mocks done, we went to go ahead and build this. And our first challenge that we needed to deal with was how do we actually manage the identities? So our first screen, welcome to Space Finder, sign up, sign in. You know, how do we actually store our credentials? How are we going to pass these flows? And so let's talk through some common patterns that customers are doing here. So the first and most basic of patterns is, well, why don't we just have a database? And in our database, we can just do a table of usernames, passwords, and plain text. You know, this is simple. Unfortunately, we do see this quite often, but this is of course, a strong anti-pattern. As you can imagine, anyone who has access to the database, whether it's your DBA or an attacker who were able to compromise access, has now immediately stolen all of the credentials. You have a data breach on your hands right away. So we can certainly improve upon this approach, and we can go out and we can hash the passwords, for instance, right? But even with hashed passwords, the reality is you could build a rainbow table, you could pre-compute the hashes, a dictionary attack would still work, and you could walk away with everything without much effort. So this isn't a good approach either. And even here, you don't want to use a very weak hash either, right? So we can improve upon this again, as many of you probably do. You can use salting and hashing. So with salting, we basically take each user, and we actually add a pre-computed or predefined salt value prior to hashing, or we store in our table. And then in addition to basically adding that, then hashing together, we can do multiple iterations of hashing, which means that even brute force cracking passwords takes a very long time and would only yield a single value of relevance for a single user at a time. So doing this at scale to brute force crack this would take a lot of effort. So this is a much better practice already, right? But what if there was a way that we could actually never send our passwords over the wire at all and not store them like this even in a database? And for that, there is such an option with something called Secure Remote Password, or SRP. And this is a protocol developed by Stanford. And effectively, you're pre-computing with big integers and numbers on both ends. And all you're storing here is effectively a verifier in your table. So the password's actually never gone over the wire. So this is a great approach as well. And this is one of our best practices we recommend. But even if we've stored our passwords well and securely, the reality is password handling and how we store that password is just one of our challenges. We also may want to do multi-factor authentication. We may want to do a CAPTCHA. We need to encrypt any kind of things at rest and transit. There are a lot of other security concerns here. Not to mention the number of flows that we want to support, from sign in to sign up, change password, reset password, etc. We have a lot of flows, a lot of UIs, a lot of complexity. What if there were a managed service that could basically handle all this for you without you needing to worry about how to implement all of this yourself in a secure way? I'm pleased to say AWS has such a service available today, and this is called Cognito User Pools. To walk you through a bit more of these flows in depth, I'll turn over to Jim to share this with you.
So Amazon Cognito User Pools is a managed identity provider. And I want to walk through two of the key flows here, sign up and sign in. So for sign up, you have a user, they use your mobile app, they register, the mobile app calls Cognito User Pools. Cognito User Pools then sends a verification SMS or email to the user. The user then can put in that verification code to verify and confirm the registration, and only at that point is a user considered a successful registered user. So that's sign up. For signing in, the user types in their username and password. You authenticate using the secure remote password protocol, so no passwords travel over the wire. Cognito then can issue JWT, JSON Web Tokens. And it actually issues 3 JSON Web Tokens, an identity token, an access token, and a refresh token. So this is a fairly simple flow. A lot of customers want to customize this flow. So to take another example, the user could authenticate against Cognito, and Cognito could actually return back a challenge, asking the user to either input their MFA code or a CAPTCHA as an example. Once the user responds to that challenge, only then would they get JWT tokens. So you can use Lambda hooks to customize the behavior of your authentication flows. And actually, at every meaningful part of that interaction with the user, you can provide custom Lambda hooks to customize whether an email is sent out, the messaging, and so on. So that user experience is totally customizable. So we talked about authentication and getting back JWT tokens. Let's look at what that means. So this is what a JWT token looks like, JSON Web Token. And it's essentially a compact way for one system to send an assertion to another system. It's an open standard, which means that there's a lot of open source libraries out there to decode and encode these JSON Web Tokens. It's base 64 encoded, and it consists of 3 parts separated by periods. The first part is the header. It just indicates that it's a JSON Web Token and the particular signing algorithm. The second part is where the meat is, and this is the payload. So this effectively contains our assertion, and we'll go into more details on this. The third part is the signature. So this is a cryptographic signature that's usually computed using the sender's private key, and this lets you verify that the particular token was in fact issued by that particular sender. So together, this is a JWT token. When you authorize using Cognito, you get back 3 of these JWT tokens, an identity token, an access token, and a refresh token. Okay? So we'll use Cognito to get those JWT tokens. For our application, we actually want to interact with AWS services. So for example, we allow the user to upload a profile image into S3. So how do we translate these JWT tokens into something that allows us to access AWS resources? So to bridge that gap, we introduce Amazon Cognito Federated Identities. And what Amazon Cognito Federated Identities helps you to do is exchange authorization tokens for temporary AWS credentials. So this is what that looks like. Your user authenticates against Cognito user pools, gets back those 3 JWT tokens. Then it makes a call to Cognito Federated Identity, passing in that identity token. It'll get back a unique identity ID corresponding to that user. It makes one more call to ask for AWS credentials, passing in the identity ID that it got earlier, along with the identity token that it got from Cognito user pools. Behind the scenes, Cognito Federated Identities will then make a call, assume an IAM role using AWS Security Token Service, which then returns back temporary AWS credentials, and then it hands back those credentials back to the mobile app. And those temporary AWS credentials consist of an access key, a secret key, and a session token. And we'll take a closer look at that. So that's great. Now our mobile app has AWS credentials. It can now use the standard SDKs to interact with any AWS service, such as S3. So to kind of show how this works in practice, I want to go through a quick demo and show how we configured our user pools and federated identity. Can we switch over to the demo? OK. So this is our Space Finder user pool. And I'm not going to touch on all of the configuration options, only some of the key ones that we think are worth mentioning. So a Cognito user pool has a unique pool ID. And we created some sample users. We created a couple of normal users, as well as an administrator user. And out of the box, each user can be associated with some standard attributes. Attributes such as first name, last name, email. For our application, we also wanted to distinguish between normal users and admin users. And so we actually created a custom attribute, in this case called custom admin, that will designate whether a user is an admin or not. So you have one user pool. You can have multiple applications accessing the profile information in that user pool. So we have 2 applications here. The first one is our mobile application. So our mobile application, it has its own unique application client ID. And we've configured it to require SRP authentication. And we've also configured the mobile application to have access to certain attributes, such as the email, first name, last name, as well as the custom admin attribute. But you'll notice that our mobile application does not have write permissions to modify that custom admin attribute. Okay? We have a second application configured here. And this is our back-end application that actually provisions the users, that actually creates the admin users. So it's got its own unique application client ID. And in this case, we have the option of disabling the SRP, the secure remote password authentication. We can secure it using other means. And typically, we would define an application client secret. And what you'll notice when you look at the permissions for this particular provisioning application is that it has full permissions to read or write any attribute. And so you have one user pool, but you can have multiple different applications accessing that same user profile information, each with its own permission set. OK? And I want to show you the mobile application that we built. So Space Finder allows you to look at bookings, be able to book a room. And if I click around here, you'll notice that I can't see anything. I'm not signed in yet. Okay, so everything I'm going to be doing here on this mobile phone, you can see in this window here to the left. And what we did is we enabled Chrome debugger tools so that anything I do here, any of the debugging output, you'll see it right here on the screen to the window to the right. So you can get a behind-the-scenes view of what is happening. OK, so I'm going to click around. I can then register as a new user. So let me just register. And we already pre-filled out this form. So I'm going to register as a new user, Jim, first name, last name. I'll click Sign Up. And it says Sign Up Successful. And it sent me an email with a confirmation code. So I'm going to check my email. And here's my new verification code, 963641. I'm going to go back into the application. OK, I already forgot the number. (963) 641. 963641. And I'm going to then confirm sign up. Great. I'm now successfully registered. So I can now sign in. So I'll just click on sign in on the upper right hand of the screen. And I sign in. Let me change my username to Jim, which is my new user here. And I use that default password. And I'm going to sign in. It's going to authenticate against Cognito user pools and success. So I wanted to walk through what's happening behind the scenes here. So I authenticated against Cognito user pools, and I got back 3 JWT tokens: the identity token, an access token, and the refresh token. So let's take a quick look at each one of these. So I'll take the identity token, and I want to decode it to see what's inside. So if I copy and paste it here, I'll decode it. And you'll see we have the header, which represents that it's a JWT token. And the payload is what is interesting here. So if I zoom in, you'll see that the payload includes my Cognito user pool ID, as well as my username, Jim, my first name, my last name, and my email address. So it has the profile information that I configured earlier that the mobile application can access. So that's what comes back as part of this JWT assertion. It also has an expiration. In this case, identity tokens expire after 1 hour. So let's take a look at the other token, the access token. So the access token has slightly different information. Oops. So the access token has the Cognito user ID, but it does not contain any of the profile information. What you use the access token for is to make calls to Cognito user pools to modify attributes about that user. So the identity token can be used by the front-end app, but the access token is really used for interacting with the Cognito user pools. And like the identity token, the access token also has an expiration, in this case of 1 hour. So that's our identity token, our access token, and then what you use a refresh token for is if your access token has expired, you can present the access token along with that refresh token and get a new access token. So that's what the refresh token is for. OK, so going back to what else happened behind the scenes. I got my JWT tokens. I now need to exchange those JWT tokens for temporary AWS credentials. And so to do that, I made the calls to Cognito Federated Identity. I got back my unique Cognito user ID, as well as the temporary AWS credentials, the AWS access key, the secret key, as well as the session token. So now let's try actually doing something with this. So if I go to my account page, I have the option of uploading a profile image. I'll click. OK, I'll just clear this. So I have the option of uploading a profile image. I'll select an image. It pops up the image selector here. I'll select a photo I took of myself last night. And you can see it's uploading to S3. And it used those temporary credentials using the AWS SDK to make a normal upload. How did it know that it had permissions to upload to S3? That goes back to the IAM role that we associated with the Cognito federated identity in the first place. And that IAM role, in this case, allowed us access to API gateway and so on. And here's the S3 portion of it. It allows us to put an object into a particular S3 bucket under a particular key space that's specific to that user. So if I change this now from an allow, I'll change it to a deny. I'm going to try this again. I uploaded the permissions associated with that Cognito federated identity. If I select an image, select my photo again, it'll try to upload to S3. And you'll see, in this case, we now get a 403 status code forbidden, error uploading image to S3. And so those permissions that you associate with your Cognito federated identity is what determines what permissions your app has when it's trying to access AWS resources. So just for good measure, I'm going to just change this back to allow. And I can just try it one more time. And I should be able to upload my image this time. So this was just an example of how you authenticate against Cognito user pools, get back your JWT tokens. You take those JWT tokens, call Cognito federated identity, and exchange them for credentials that you can use to call AWS resources. And with that, I'll turn it over to Justin.
Thanks, Jim. If we could go back to the presentation, please. So as you've just seen from Jim, we now have a way to sign in our users with Cognito user pools. We have a way to get tokens for them and exchange them for AWS credentials. But the core of our business logic in our app is actually not in S3 or even in a Dynamo table, but rather in an API we would like to have. So following the serverless pattern, our application uses API gateway, Lambda, and DynamoDB to do all of its persisted state. And so when you look at our API, this is our API structure. So it's a standard RESTful API, different paths for users, different things here. But the key thing that's worth mentioning is that we have admins who should be able to create locations or delete locations. And we have certain operations on our API that we only want certain users to be able to do. So let's talk about the different options available for us to do authorization with API Gateway. And there are three choices we have to look at today. These include user pool authorizers, IAM-based authorization, and custom authorizers. And so we'll walk through each just so you can see how they work. So the first one, which is the most simplistic, is user pool authorizers. So for those of you who may be interested in user pools, what you've seen today, or maybe already using user pools, this is a great option for you, potentially, where we can essentially do yes-no type authorization. The key thing to note here is that this will answer, is it a valid user in the user pool, yes or no, and that's it. So there's no way to actually say, more complex permissioning than that. But just to walk through what this looks like, as Jim showed you, we authenticate with user pools. We get back a set of JWT tokens. And we then take that identity token we got back, and we actually make an HTTP request, injecting the identity token into our authorization header on that request. When API Gateway receives this request, it parses the authorization header, can validate the signature based on the JWT semantics that we saw. It also knows for that user pool, from the header of the JWT token, which key should be used to sign that, so it can know it's from the right user pool. And assuming that's a valid user, it will go ahead and let the user go ahead and invoke the Lambda function, as their call would imply and is configured. And then from the Lambda function to DynamoDB, we actually are using the execution role of Lambda to do all of our DynamoDB state manipulation, or anything else that we want Lambda to do behind the scenes for our API. The key thing to note here is that all authorization logic around if that user is valid or not is exclusively in API gateway related to our user pool. So once we get to Lambda, Lambda has no awareness of the user unless you're passing something. It doesn't need to know anything about the authorization logic. It just needs to know about what the business logic is and what it needs to do. So we've offloaded that burden just to our API gateway resource. So, but what if we want something more than yes/no type authorization for our users? Or what if we're federating other sources? As Jim talked about with federated identities, we could have users coming from a variety of different places, maybe Google, maybe Facebook, social identity providers out there, maybe even your corporate identity providers, right? All of those can be exchanged to get AWS credentials and assume an IAM role. And so with IAM-based authorization, once you've done such an assume role operation, then that's where this would come into play. To walk you through this flow, you would call out to authenticate with that third party, in this case user pools, but the reality is it could be anything supported by Cognito federated identities, social identity provider, enterprise identity provider, OpenID Connect, SAML, etc. Then you get back tokens from that provider, and you pass that token into Cognito federated identities to get your AWS credentials back after the token's been validated. So for user pools, you pass the identity token. Once you get your temporary AWS credentials back, and you have the three different pieces of that IAM role that Jim talked about, you make a standard AWS API request using a process called signature v4 signing, SigV4 for short. So for those that may not be familiar with this, every AWS SDK that you use, every API that it calls, behind the scenes, the SDKs implement this signing process for you. And here, what happens is you actually take those creds, and the nice thing is that API Gateway can even generate an SDK for your API that will do the SigV4 signing without you having to implement it yourself. Once you call API Gateway with the signed SigV4 request, it can look at the credentials that signed the request and know that it was from this role, can evaluate a policy, and then based on the policy of that user, can tell if they're allowed to invoke the API or not. Assuming they are allowed to invoke the API, we would call Lambda just as before, and then our execution role for Lambda would be used for DynamoDB. So, what does a policy look like, right? This is a sample IAM policy as it relates to API Gateway. So the key thing to note here is that there's an action called execute API invoke. And that's the only key action you need to worry about in an IAM policy to specify which paths of an API Gateway resource you could call or not call. So for simplistic purposes in this policy, we've basically whitelisted the entire API, but then we've blacklisted doing a post operation for locations or any subpath beyond that. Now, as a best practice, you would not really want to have a whitelist approach or where you're blacklisting only prohibited operations, because maybe your developers are adding to the API all the time and they forget to update the policy, and now users could do operations you didn't intend them to do. So as a best practice, you might want to do a whitelist type of approach instead, but this shows you how it goes. And then the final type of authorizer is custom authorizer from API Gateway, and this is the most flexible choice of all three. So just to show you here, say you're using a social provider like Google, Facebook, log in with Amazon, any provider that can give you a bearer token back. What you can do here is you can go to that provider and authenticate to that provider. Oh, also this could be a managed identity provider or a third party, right? There's several identity services out there. This would include them. You can authenticate with that provider directly, get back your set of tokens or tokens, and then you would take the token of your choice and you would put it in a header of your choice, most commonly the authorization header, and sign your HTTP request. Well, I shouldn't say sign. Inject the authorization header into your HTTP request to API Gateway with that token. Now, when API Gateway gets this token, it looks at its cache and says, for this token, do I know what effective permissions this user should have in my API? If it doesn't know, and if it's not previously cached and still valid, what it will do is we'll fire a Lambda function, your authorizer Lambda function, that then can go out and have the business logic of your choice to go out to Google or any managed identity provider you want to actually authenticate the user there or validate the signature or any steps you'd like. But ultimately, the function must return back a well-formed IAM policy to the user. So after you've done whatever you'd like with case statements or if conditions or whatever business logic, you send this policy back. Once the policy is now an API gateway, it gets cached for an amount of time. Standard amount of time is 5 minutes. And we evaluate that policy against IAM to look up if that user is able to call the given operations that they're trying to invoke. Just as before, if they're able to call those operations, we invoke the Lambda function. Lambda will go on to do any other kind of thing you want, in our case, DynamoDB state manipulation. So this is a custom authorizer. But at first glance, you might say, gosh, how do I write a Lambda function that generates an IAM policy for me? Well, the good news here is we actually offer a custom authorizer blueprint in Lambda. So if you just go to create a Lambda function, you have blueprints that pop up. Search in the blueprints for authorizer, and you'll see that there's 2 different languages already supported with the out-of-the-box custom authorizer function, and helper utilities and classes and things like that. So with just a few lines of code here, we can actually generate an actual well-formed IAM policy and just really focus on our business logic in that function and very little else. So I was able to get my first custom authorizer function running in less than 10 minutes to tell you actually how easy it could be done. In summary, there are 3 different authorization types for API Gateway. User pool authorizers, the simplest for yes/no authorization, for user pools exclusively. And then IAM-based authorization with SigV4 signing, as well as custom authorizers. Now, unless you have just the need for user pool authorizers, our best practice would be to go with IAM authorization or custom authorizers throughout your API. To make this more real, let's go ahead and cut over to a demo. I can show you each of these working so you can see how they play out. So here we are again, back in Space Finder. Let me go actually into, close this guy. Let me go here. And so we can go into API Gateway. And OK. So here on the right, for those that may not be familiar with API Gateway, we have our entire API, all of our resources and operations. And then per operation, we can actually set the type of authorization we want for that operation. So in this case, a list or a get on our locations resource, we're going to use a user pool authorizer. And then for our create a location option, which is admin only, we're using a custom authorizer. One thing that's important to note is that when you look at a method request, you not only have authorization in here, but you also have API keys. Some customers I've seen this pattern, and I'd like to just help people understand that API keys, as far as API Gateway goes, are not meant for authentication. The difference is that with an API key, it's a static string that would be used for you to track a usage plan or quota or throttling for a user, but not to actually authorize them. And the reason why is with an API key, it's a static string you're injecting, but the string never changes and never expires. With all of the approaches we've talked about, all of our tokens are time limited, most of them for 1 hour at most, and it's a much more secure approach than using a static string that could be compromised and used indefinitely. So to go ahead and make this more real, let's go back to Space Finder again. OK. So here we are in our app. OK. So let's go over to resources. Let me actually clear this. So I wanted to show you what happens if you call an operation where you've required authorization, but you don't actually send the authorization credentials. So let's try and load locations without auth. OK. We send a GET request. We get a 401 back saying we're unauthorized. We don't know who you are. You didn't send us headers. Let's try this again. Clear the log for simplicity. And this time, we'll use a user pool authorizer. So if you notice, we're sending a GET request here. And just zoom in on this a little bit. we're sending one header with our request, which is our authorization header, and we're passing the user pool's identity token as that credential. Now, as you can see, the request worked. We have our locations back. So let's go into the Venetian here. And we want to actually load resources now, right? So this is an example of IAM-based authorization. And with IAM-based authorization, as you can see here, we do a GET request, but we needed to sign the request. So unlike the other authorizer types, we're actually even signing the payload and the entirety of the request. And if I open this up, just to show you all the headers, there's actually more headers involved than just the authorization header. There's that, which includes the signature, but there's also headers like X Amazon date, X Amazon security token. So SIG before signing is a little bit more than the other approaches, right? And it's more all-inclusive in terms of looking at the entirety of the request. Obviously, the GET request worked, so let's go into, say, Opaline Theater, place that sounds familiar. And I hear there's an event going on today at 11 a.m., so let's reserve the space. So if we go in here, let's book the space. This is another example of IAM authorization, and this is a post. And so the difference now, for the first time, we have a body with all of our semantics, but we're sending the fully signed request again with all of the headers, and we can see that the request was successful and authorized. Now if we go, as you can see, just going to our bookings, we can now see that our bookings are there. So our state has been persisted. But what we haven't shown is we haven't seen a way to differentiate our admin users with either of these approaches that we've shown so far. So in our app, let me actually show you under account here. We have a little toggle. Even though I'm not signed in as an admin, let's turn on some admin features so we can actually see what happens. And if you notice, we now have an add a location option in our app. So let's go ahead and try and add a test location. And we're not logged in as an admin, right? So this is not likely to go well. And as we can see, we get an error back. But this time, it's not a 401, it's actually a 403, meaning that we did send authorization header, and we know who you are, but you're just not authorized to do this. So that's the difference. So let's actually show, if I were to go ahead and log out, let me log in as an admin. Our username here. Just plug this in again so we can fix this. Okay. Let's go ahead and log in as admin1. And now, as before, we're signed in. We got a new set of tokens back. This time, as admin1, let's go ahead and do the same thing. Add the test location. Add a location. And unlike before, we didn't get an error. So if I load my locations again, you'll actually see that we have our new test location back. We also are using custom authorizers for our delete locations. So just the same, I can now do a delete request and successful. So to show you how you can actually test this easily in the API Gateway console, I'll cut over and you can see this at work. Let me grab our admin token. Let's grab the identity pool here, user pools. And if I go into API Gateway, we can actually go into our authorizers, where you can see we have our user pools authorizer, where we can take our token and we can actually test it directly. Oh, I may not be logged. Let me do it for custom authorizer. I may not have pasted it properly. Go back. Let's grab this one more time.
You have an extra space.
Oh, yeah, let me kill the space. That's my issue. So if I go down to custom authorizer, see, it killed the trailing space. You guys get to see live troubleshooting, so you're in luck. Try it here. Let me just try and sign out and sign in as the other user and get some new tokens.
I think you're copying the space at the end.
Okay, I think I killed it, but let's try that again. We signed in. Okay. So let me actually just start at the end and work back. There's a space there. Obviously, this is a lot easier when you're not copying and pasting the console and you're doing it programmatically. If I go in here, here we go. So we can see for our user pools authorizer that we actually have this user set up, and we got, even though it's just showing us the identity token for good measure, the effective response is it's a valid user. And you can see that custom admin is set to false. This is not an admin user that I just signed in with. If I go into custom authorizer and I run the same identity token, what we'll get back, taking a little longer because our Lambda was a cold start, likely, is you'll see that we got a well-formed IAM policy. And so this user, much like we showed earlier, was allowed to do generically most things in the API, but we have a deny statement that denies posting and deleting locations and any subpath. And in IAM, given that deny statements trump allow statements, the effective permissions for that user was deny. Let me sign back in as the admin just to show you the difference so you can see. There's this console log. Okay, we're signed in again. Let's go and grab our identity token. Okay, now we'll just try the custom authorizer. The user pools authorizer would look the same because they're both valid users. But if I try the custom authorizer, you'll notice now our deny statements are gone. So this admin is allowed to do anything in the API without any deny conditions, showing that we've used business logic in our Lambda function to actually parse that custom admin property and decide what we want to return back. And this is now good for 5 minutes time with our default settings. So if I make another call just in the next minute, I don't even need to run the Lambda function again and have any latency or additional cost from the Lambda usage. So now that you've seen all of the API gateway authorizers and settings in practice, the one final thing I would mention is that our API, for demonstrative purposes, uses a hodgepodge of all three. In reality, this adds complexity to your API and to your client-side developer experience, so I would not suggest using more than one if you can avoid doing so, even though you have the flexibility in the platform. So to go ahead and talk a bit more about enterprise identities, I'll go ahead and turn it back to Jim to discuss SAML. And if we could cut back to the deck, please.
So we talked about integrating with Cognito user pools, with OpenID Connect providers, with other providers that provide authorization tokens. In an enterprise setting, SAML is a fairly common standard for doing identity federation. So here's our architecture so far. How do you actually integrate a mobile application with a SAML provider? And it turns out it's actually not trivial. So in an enterprise setting, you're going to have an identity provider, typically Active Directory or Open LDAP, and then the SAML provider, such as ADFS, Active Directory Federation Services, or Shibboleth. And the fact of the matter is, SAML 2.0, that spec was ratified back in 2005, before the first iPhone even launched. So it really wasn't built for a world where there was mobile applications. And SAML 2.0 supports two different bindings, a post to a particular URL endpoint or a redirect back to a URL. And so in a mobile app, capturing that SAML response just is not trivial. For example, what do you redirect back to? if you're using a mobile app. So at a high level, the pattern for integrating SAML with a mobile application is still very similar. You would want to authenticate against your SAML endpoint, against ADFS or with Shibboleth, which in turn calls Active Directory or Open LDAP. And then if you have that SAML token or that SAML claim, you can then use that to trade up for AWS credentials. But it's really this step between 1 and 2 where a lot of the complexity and the complication is. And so the workarounds for doing this are either, 1, actually have a web view within your mobile application that can actually intercept that redirect, or 2, actually create a proxy service, which in turn calls the SAML endpoint and then exchanges the SAML claim with the cognito federated identities. So it's either a proxy service or some very arcane web view scraping. So this is the challenge with integrating SAML with a mobile application. And then, of course, once you have AWS credentials, you can then exchange it for, you can use that to access other AWS resources. So the fact of the matter is, SAML just wasn't built for an age where mobile applications were ubiquitous. It is possible. In the next few weeks, one of our specialist SAs, Richard Threlkeld, he's publishing a blog post on how to set that up. But it actually is fairly convoluted and a series of workarounds. So wherever possible, if you are using a newer version of ADFS, such as ADFS 2016, that supports OpenID Connect, use that instead. So use the standard authentication tokens whenever possible. And one last demo here. Can we switch back? So it doesn't have to be this choice where you choose either a SAML provider or Cognito user pools or an OpenID Connect provider. With federated identities, when we configure our federated identity, we have the option of associating it with multiple identity providers. So just as an example here, in our case, we configured it with those Cognito apps, right? Our mobile application, as well as that back-end provisioning application. But if we wanted to, we could also associate other identity providers, such as Amazon Login, Facebook, Google, Twitter, OpenID, SAML, or if you have your own custom identity provider, you can do that as well. And so the key here is you have a Cognito federated identity supporting multiple identity providers. So for example, if I were to log into an application using my Cognito user pools login, and then later log in with my Facebook login, those can both be associated with that same unique user ID. Okay? So that's how you tie it all together. And then one last demo I want to do is we built this application so that it would be easier for you to look at the code, understand the flows. A lot of these details are fairly specific in terms of what tokens to pass and what orders to call things in. So I just wanted to show what it takes to actually get this demo up and running for yourself. So we have the GitHub repo, and we'll show the URL at the end. And this repo has our architecture diagram, and we have all the steps to actually set up the prerequisites on your system, such as installing Gulp and Bower and so on. Once you have that installed, then setting it up, CD. Once you have it installed, then setting up is very easy. You can just do a Gulp bootstrap. In this case, I've already bootstrapped it. But if you do a Gulp
API folder.
Oh, sorry, CD API. If you do a Gulp deploy, we've automated this entire process for you. So we'll set up the S3 bucket. We'll set up the API gateway. We'll configure the Cognito user pools, configure the Cognito federated identity, set up the Lambda functions associated with the API gateway, configure those authorizers. So all of this is fully automated for you. You can see it's right now uploading the Lambda functions. It's creating it. And then once that's done, your environment is set up. Then now to test it, you can either generate an APK that you can download on your Android device, or you can also create an iOS app. But you can also test it with a web browser, just doing Ionic serve.
App folder?
Oops, yeah, that's in the app. And if you do Ionic serve, this will actually bring up a browser window that looks just like the mobile application window, because this is a hybrid mobile app, where you can actually test all the functionality that we've shown you, look at the browser logs. So here's the mobile app. It runs identically, so I can sign in. I can upload the image. In this case, it's going to use the browser image upload functionality instead. OK? And so you can test this all. And in terms of viewing the debug logs, just open up your JavaScript console. So we made this to make it easy for you to understand the flows in more detail, check out the code, try it out, and hopefully it'll help jumpstart your project. So can we switch back to the slides?
Do you want to show them how to undeploy? Or?
Oh, sorry. One last thing. Can we switch back to the demo? And of course, now you have all these different AWS resources. Once you've done the demo and you've understand some of the flows, we've also created an uninstall script for you. So that's simply go undeploy. And that will delete the Lambda functions, do everything in reverse, right? Get rid of the API gateway, remove the custom authorizers, delete the S3 buckets, and so your account is clean. And so you can try this as many times as you want. And really, it's to make it easy for you to use it for your teams. OK, so back to the last final slides here. Can we switch back to presenter? OK. So just to wrap up, we talked about how do you build a serverless mobile application that supports identity management. We talked about using Amazon Cognito user pools as a managed identity provider. We talked about trading those tokens using Amazon Cognito federated identities so that you can have AWS credentials. And then we talked about some of the gotchas and workarounds for integrating with an enterprise identity provider using SAML. And with that, you can then access your AWS resources. You can provide very fine-grained access control for your APIs. And everything we talked about here doesn't just apply to mobile apps. All of these flows and patterns also apply equally well if you're building a serverless web application. And so please do try this at home. We just open source the repo. Would love any contributions and any feedback. And hopefully, this is useful for your team. And so with that, we do want to thank you for joining us today for this hour. And OK, I'll just leave this here. And thank you very much. OK, I think we're done. Yeah, thank you.